Hey, my name is T, and
My name is Joseph.
we're working on the quantum melt and heat diffusion final project. So this project is about implicit functions and solving equations. So here are the tasks that it asks us to do. Tasks 1 all the way through 8. And if I close this and go to MATLAB real quick, you can see on this left hand side is our command script, is our script that we wrote, and on the right hand side is our MATLAB. Um, so
For
for
okay,
yeah, go ahead.
for task 2 and for task 3, we have the input command, and for task 2 we have to input n. N is the variable that dictates pretty much the range of the interest that we want later on when we graph our function of cotangent x equals square root of x naught over x minus 1. And for x naught we have also the input command, and also for s is the variable as assigned to the number of solutions that the user want. And for task 4 we have our is empty command, which is the loop for to help set up a default parameter for each variable, just in case the user did not enter any values for the variables n, x naught, and s, or if they accidentally hit return or enter, then n would equal to 1000, x naught would be 20, and s would be 5.
Okay, and then we have task 5 and 6 right there. Task 5 is just a linspace command that we put, and then task 6, we use linspace to graph the left hand side and the right hand side of the equation. The left hand side is the cotangent part, and then the right hand side is the long x squared divided by x squared minus 1 over this to the square root of all that. And then we put the little r over there so that we can define it as the red graph instead of both graphs the same color. And we limited the range of both the left and the right hand side so that it would give a more clear graph at the end rather than a one big graph. And then on task 7, it's a pretty big loop that we made. Basically all it's doing is calculating. It's gonna ask for a number, and it's gonna ask you to enter the interval of desired solutions, and then after you enter that interval, it's gonna calculate everything, and then it'll give you the closest possible solution to the error. And then if you enter a solution that's too big, it would display the value of m exceeds the maximum possible value. And then we have task 8, which is again another big loop. Here, if you happen to enter 0 on task 7, it would ask you, do you want to find another solution? If you put no, then it'll be finished with the display of alright, I'm done. And if you don't enter anything, it's gonna say sorry, I don't understand. And then if you enter yes, it's gonna go back into this loop one more time. So to go back into the loop, what we just did is we copied part 3 to 7 from the above, just all in here, so that it wouldn't be that difficult of a thing to do, and it's just a one big loop. And if you enter 0 here again, obviously it would go back to the top and ask you, do you want to find another solution? And then to give a little quick show of the program, let's run it on MATLAB. So input a solution for n. Let's put all that as default, and then when you do all that as default, you get the graph right here, and you can see the blue graph is the cotangent, the red graph is the graph of the right. And then interval desired solutions to given the interval, sorry 5.
Not until we start it again, because we forgot to put the maximum error.
Sorry guys. Okay, put maximum error 5, and then here's a more accurate graph. with interval of 5, and then desired solutions. If you enter things, it'll give you a number, but if you enter something that's too big, it's clearly gonna give you the thing that display that says it's too big. If you enter 0, it'll ask again. If you enter yes, what I did up there, it'll just go back into the loop, and if you enter no, it's done. Alright then, that's our script, and thanks. Ciao, buddy.